Hello students, today we will discuss inverse of a function. This is also one important concept from functions. F from A to B be a function. They're interchanging domain and codomain, getting one new relation. Right, G from B to A be the new relation. This relation becomes function, then this relation is called inverse of f. In this case, we should write G is equal to f inverse. That implies f inverse from B to A. Suppose this is a function, then this is called inverse of f. Now observing, A, this is B, f is a mapping from A to B. Suppose x is an element in domain A. Suppose its image is y. So x is connected to y. Generally, the image of x, how to write? Under f of x. That means very clear, y is equal to what? F of x. F of x is the image of x. Okay. Now, interchanging domain and codomain. This is a mapping from B to A and denoted as f inverse is a mapping from B to A. So, this is y. Y is connected with x. Here, the image of y is x, very clear. Now, the image of y under f inverse, how to write symbolically? F inverse of y. Very clear, this f inverse of y is equal to what? X, because x is the image of y. So, x is equal to what? F inverse of y. From these two diagrams, observing one important point, one important statement I will write now. Y is equal to f of x if and only if x is equal to f inverse of y. Okay, f from A to B be a mapping and f inverse from B to A is a mapping. Then f inverse is called inverse of f. From this concept, we should write one statement. Y is equal to f of x if and only if x is equal to f inverse of y. This is a very useful and important statement by calculating or estimate the inverse of f for given function. Now, how to calculate inverse of a function? So, one statement I will give, remember, that is f is bisective mapping if and only if f is invertible. Invertible means the function having inverse. Bisective means the function is 1, 1 and onto. Now one rule I will tell. F is 1, 1 and onto, then f is invertible. That is the function having inverse. That's why here, before calculating inverse of a function, just identify the given function is 1, 1 and onto. Any one condition will fail, inverse does not exist. This point remember. Okay, now through applications I will explain how to calculate inverse of f. But remember this point very useful. Okay, right. I will give one application. F from R to R defined by f of x is equal to x minus step x. Then f inverse of x is, this is also one of the JEE Mains question. Observing here, f from R to R defined by f of x is equal to x minus step x. Then its inverse is what? So what I told here, observing, the function is 1 1 and onto are not checked out. That is the primary verification. Okay, so the function is bisective or not checked out. So bisective, inverse will exist. Okay, now observing here, clearly f of x is equal to x minus step x is nothing but x is equal to what? Fractional part of x. Always x minus step x is what? Fractional part of x. Now very clear, 0 less than or equal to fractional part of x is less than 1. That's why what can you observe here? Every element of domain connected or related to either 0 or 1 lie between 0 and 1. Every element of domain connected to between 0 and 1 and 0 also. That's why range of the function is what? Therefore, range of f is left close, right open, 0, 1. Very clear, our codomain is R. That's why this is not equal to R, codomain. What's the condition for onto? Already I explained in the previous videos. The range of the function is equal to codomain of the given function. Then f is onto. Here both are not equal. That implies what? F is not onto. That implies what? F is not bisective. That's why F inverse does not exist. Understood? Right. One more question we'll discuss. Here, observe here, f from left close right open 1 comma infinity to left close right open 1 comma infinity. The function defined as f of x is equal to 2 power x into x minus 1. Then f inverse of x is. This is also one of the IIT bit. First of all, observing here, the given function is 1 1 and onto. Okay, right. First to find out its derivative. What happening? One trick I given in the previous videos, how to verify the given function is 1 1 or not 1 1. So first to differentiate now. So 2 power x into x minus 1, that is 2 power x into x minus 1 into log 2 into derivative of x square minus x, that is 2x minus 1. This is the derivative of the given function. Here what is our x? X belongs to left close right open 1 comma infinity. That's so what about this value? Less than 0 or greater than 0? Very clear, exponential function greater than 0. Log t is positive. Very clear, in this interval 2x minus 1 value greater than 0. That's why this product is greater than 0 for all x belongs to left close right open 1 comma infinity. That's why f dash of x is what? Greater than 0. That's why f is increasing function. That implies what? F is 1 1. F is 1 1. Now we should check out onto. Let here simple procedure onto verification. Let y is equal to 2 power x into x minus 1. Now we can solve this equation. We can separate x from this equation. That is, we should write x is equal to in terms of y. Here, using logarithms, taking on both sides logarithms, base as 2. What happening? Log y to the base 2 is equal to log of 2 power x into x minus 1 to the base 2. Then what happening? Log y to the base 2 is equal to x square minus x log 2 to the base 2. That implies, very clear, log y to the base 2 x square minus 6, or x square minus 6 minus log y to the base 2 is equal to 0. Now you can solve it. X is equal to, using minus b plus or minus root of b square minus 4ac by 2a. Okay, very clear. 1 plus or minus root over 1 plus 4 log y to the base 2 whole divided by 2. This is the value of x. Observing here, what is our x value? X belongs to left close, right open, 1 comma infinity. That's why here x belongs to left close, right open, 1 comma infinity. That implies x is equal to 1 plus root over 1 plus 4 log y to the base 2 by 2. Here reject negative sign. Why? Because you should consider, you should take negative sign also. This value does not exist in this interval because x value is greater than or equal to 1. That's why we should reject that negative sign. Then x is equal to what? This one. Now here, one statement I given observing here. Y is equal to f of x if and only if x is equal to what? F inverse of y. Okay. And before that here, what about range of this function? That is identify y value. Identify y value. Here this function defined according to the here using codomain. Left close, right open, 1 comma infinity. Very clear. This is defined. Y belongs to left close, right open, 1 comma infinity. You will take any value for y. Any value for y. Sorry, it's any value for y. Then this is defined. That's why. What about range? Range of f is what? Left close, right open, 1 comma infinity. This is equal to what? Codomain. That's why f is onto. So f is 1 1 and f is onto. So that f is bisective. F is bisective means what? F has inverse. Now how to write f inverse? Using this statement. Y is equal to f of x if and only x is equal to f inverse of y. Now already we calculated. So this is equal to what? Therefore f inverse of y is equal to 1 plus root over 1 plus log 1 plus 4 log y to the base 2 by 2, or we should write f inverse of x is equal to 1 plus root over 1 plus 4 log x to the base 2 whole divided by 2. This is the inverse of given function.